All right, let's talk about a huge challenge in the cloud-native world, the absolute chaos of trying to deploy applications on Kubernetes. Today, we're going to break down Helm, the package manager that's specifically designed to bring some serious order to all that madness. Let's get into it. So if you've ever actually worked with Kubernetes, this slide probably looks, well, painfully familiar. You know how it goes. You start with a simple deployment, but then you need a service, then a config map, oh, and a secret, and maybe an ingress. And before you know it, you are literally drowning in a sea of separate YAML files. It gets complex, it gets messy, and honestly, it's just a massive headache to manage. And all that complexity, it leads to some very real problems. I mean, how are you supposed to guarantee your staging environment perfectly mirrors what's in production? How do you update an app without manually tweaking 10 different files and just hoping you didn't make a typo somewhere? This whole manual approach, it just slows everything down, drives up costs, and makes basic stuff like versioning an app or rolling back a failed deployment incredibly difficult. So what's the fix? Well, this slide nails the single best way to think about it. You know how you use Homebrew on a Mac or apt on Debian to install some complicated piece of software with just one command? Helm does that exact same thing, but for applications running on Kubernetes. And that brings us right to Helm. It's this fantastic open source tool built to streamline how you install and manage even the most complex Kubernetes applications. Its entire reason for being is to tame all that complexity we were just talking about. Now, Helm isn't some new experimental thing. It's got a really solid history. It was first created way back in 2016, got donated to the CNCF in 2018, and by 2020, it hit graduated status. You know, that's the highest level of maturity a project can get from the CNCF. So what does that mean for you? It means Helm is stable, it's widely adopted, and it's absolutely ready for production. Okay, so to really get how Helm works its magic, you just need to understand 3 core concepts. Once you get these, everything else just kind of clicks into place. First up, we have the chart. A chart is the fundamental package for Helm. Just think of it like a neatly packed box that has all of your Kubernetes manifests inside. Your deployments, your services, everything, all bundled up into one single versioned unit. It's the blueprint for your application. So if a chart is a package, where do you find them? Well, that's what a repository is for. A Helm repository is basically an app store for Kubernetes. It's a server that hosts a whole bunch of charts that you can search for and install. The main place to find these is a site called Artifact Hub. It's got charts from tons of different projects and companies. And last but not least, there's the release. When you take a chart from a repository and you install it into your Kubernetes cluster, what you create is called a release. It's a running instance of that chart. And here's the really important part. You can install the same chart over and over again to create multiple totally independent releases. So if you need 2 separate MySQL databases, no problem. You just install the MySQL chart twice and you get 2 different releases. Okay, so we know a chart is a package, but what's actually in the box? Let's pop the lid and take a closer look at the file structure of a typical Helm chart. So this here is the typical directory structure of a Helm chart. You can see a few key files and folders right away, like chart.yaml and a templates directory. This standardized structure is exactly how Helm keeps everything organized that it needs to deploy an application. Let's break down what each of these pieces actually does. All right, let's look at what these files do. First, chart.yaml. Think of it like the label on the box. It's just metadata, like the chart's name and version. Now, the values YAML file, this is where the magic happens. It gives you all the default configuration values that get plugged into your templates. This is what makes charts so flexible. The templates directory is where the actual Kubernetes manifests live, but they're filled with placeholders that get their values from that values YAML file. And finally, the charts directory is for bundling other charts that your application depends on. Okay, that's enough theory for now. Let's get practical and see how you actually use Helm to get an application up and running in your cluster. It really just boils down to a super simple, repeatable workflow. And it really is this straightforward. First, you find what you're looking for by adding a repo. Next, you install a chart from that repo, which creates your running application, your release. And finally, you manage that release over its entire life with really simple commands for upgrading or, if something goes wrong, rolling back. In this slide just shows you how incredibly simple that workflow is in practice. That first command adds the super popular Bitnami repository to your system. And the second command, it uses that repo to install a MySQL chart, creating a release named MyRelease. I mean, think about that. In just 2 lines, you get a fully functional MySQL database running in your Kubernetes cluster. It's awesome. Now, here's the really crucial thing about Helm. It isn't just for installation, it's all about lifecycle management. Do you need to update your application to a newer version? You just run Helm upgrade. And here's the best part, this is the real game changer. If that upgrade fails or it introduces a bug, you have a safety net. Helm keeps a revision history of every change, so you can instantly go back to a previous working version with a single Helm rollback command. This just dramatically lowers the risk of pushing changes to production. So now that we've got the core of Helm down, let's kind of zoom out a bit and look at the bigger picture. We're talking about the whole ecosystem, security best practices, how Helm stacks up against other tools, and what's coming next for the project. Security is obviously super important, so here are a few key things to keep in mind. First, and this is a big one, never hardcode secrets directly in your values YAML file. Second, don't fall into the base64 trap. Remember, that's just encoding, it is not encryption. Anyone can reverse it. Third, for your own internal sensitive charts, use a private repository. And finally, always lint and validate your charts to catch problems before they ever get to your cluster. A question that comes up all the time is how Helm compares to another tool called Customize. And here's the simplest way to think about it. Helm is a full-blown package manager. It's perfect for distributing complex, off-the-shelf software like a database. Customize, on the other hand, is more like a patching tool. It lets you modify your existing Kubernetes YAML files without using templates. That often makes it a simpler choice for managing your own in-house applications, especially if you're using a GitOps workflow.
So what about the future? Well, Helm is already a super mature, stable project. But it's not just sitting still. Helm 4 is actually in active development right now. The focus at the moment is less on flashy new features and more on just shoring up the foundation. Fixing bugs, improving documentation, and really just getting the whole ecosystem ready for the next wave of cloud-native development.
So we've seen how Helm can completely standardize the way we deploy third-party software. And that leaves us with one last, really important question to think about. Helm gives you the tool, but the strategy, that's on you. So how are you going to use it to create and share standardized reusable charts for your own internal applications to bring that same level of consistency and efficiency to your own teams?